Hi, this is Preston Winger in Emberg. Today we're going to be looking at Introduction to GIS Softwares. Okay, and the material that the material I'll be discussing, these are the links, the sources where we are deriving it from. So, Introduction to GIS Software, how data are stored in ArcGIS, components of ArcGIS, ArcMap, um, GIS on the web, extension of GIS, spatial analysis. Okay. And we go on. Geographic data modules. All geographic information systems are built using formal models that describe how things are located in space. So a formal model is an abstract and well-defined system of a concept. So a geographic data model defines the vocabulary for describing and reasoning about the things that are located on Earth. Geographic data models serve as the foundation on which all geographic information systems are built. So this is geographic data models. Hello, you're done? See you tomorrow. Okay. Data models. A geographical data model is a structure for organizing geospatial data so that it can easily be stored and retrieved. Okay. File-based data models, geographic coordinates and attributes are stored in separate but linked files. So coverage developed for web stations in 1980, then shapefiles 1993. Storing data. Okay. Coverage in the shapefiles. Coverages are stored partially in their own folder, that is ARC, and partially in the common info folder. So shapefiles are stored in 3 to 5 files with extensions, which is .shape, .shx, dbf, sbx, and sbn. So coverages store common boundaries between polygons and only wants to avoid redundancy. Shapefiles store all geometry of each. Coverage features are single lines or single polygons. Then shapefiles allow features to have multiple connected, intersecting, and overlapping component. Geo data base and feature dataset. A geodatabase is a relation database that stores geographic information. Then a feature dataset is a collection of feature classes that share the same spatial reference, okay? As you can see here. Geodata model stores geographic coordinates as one attribute shapefile in a relationship table. Uses MS Access for personal. Geodatabase uses single. Okay, so they use Oracle SQL, okay? And this is how it will look like. So workspace and everything is documented here. Object class. An object class is a collection of objects in a tabular format that have the same behavior and the same attribute. like you can see here, this is the database, and this is how they are. So an object class is a table that has a unique identifier, which is the object ID for each record. Feature class. A feature class is a collection of geographic objects in tabular format that have the same behavior and the same attributes. So feature class, objects class, and special coordinates, okay, same behavior. Relationship. A relationship is an association or link between two objects in a database. A relationship can exist between spatial objects, features in feature classes, the non-spatial objects. Okay, so the relationship between non-spatial objects. So here we're dealing with water quality, and we are able to see the relationship. There we are again. Network. A network is a set of edges, lines, and junctions, points that are topologically connected to each other. So each edge shows which junctions are its endpoint. So each junction knows which edges it connects to. So this is a network, which looks like a tree or maybe branches. Introduction, how data are stored in ArcGIS. Okay, components of ArcMap, okay, GIS on the web. So with the Arc server, online in the extensions, then view and edit data to be like this, creating maps, something like this. Then view data like Windows Explorer. It will give us like this, an catalog, or give us like this, and the Arc toolbox or have all these tools. For example, 3D analysis tools, conversion tools, and so on. So all these are tools. Then Arc tools again. Okay, like the tools, then you can even see um, the map projection and everything. Then geoprocessing. So this is how this model will look like. So tools, toolbox tools linked together using the model builder to automate data processing. ArcGlobe, an alt-native display to ArcMap, are designed to rapidly display image files and to zoom in rapidly from a global view to a local view. Works on a spherical Earth not spheroid. Okay, so there we are. That is our ArcGlobe. Levels of ArcGIS. Okay, so we have the ArcView. View data and do edits on shape, files, and simple personal geodatabase. Then Arc Editor, do more complex edits on enterprise geodatabase. Arc Info, the full system with access to workstations and info. Then License Manager. Okay, so this is how it looks like. The License Manager keeps track of number of simultaneous users and limits them to allowable number. If you can't get an available license in AORC, ask the proctor to restart the ArcGIS License Manager at USU. Then you contact the person to contact there and so on. How data stored in ArcGIS? So components of ArcGIS. So GIS on the web, Arc GIS server, ArcGIS online. Okay. So desktop server, web. So desktop server, their web. Arc desktop will look like this. Then the Arc server will come and look like this. Okay, so this one is the Arc Resource Center. Then we have the world map sheet or street map. Then world road base map. This is Texas. Okay. Here, Google Earth 3D with terrain. Experimental watershed data, ice water. Okay. So this one comes to display then observations, data in the Google Earth. Okay. So this is how it will look like. Then extensions, ArcView, ArcEditor, ArcInfo. ArcGIS Special Analysis, Advanced Raster Modeling. These are the things that we actually find. Then ArcGrid Calculator with algebra that is on the Arc analysis. Then ArcGIS 3D analysis. It's a real-time interactive 3 dimension. So this one is real-time, meaning things will keep changing as we work on them. Then your statistical analysis, advanced terrain and surface modeling, analysis of the land surface terrain. Okay, this is how it looks like. Then grid data set. These are cellular-based data structures composed of squares. Squares are cells of equal size arranged in rows and columns. Okay, as seen from here. Just statistical analysis. This is an interpolation of points to grid using statistical operation. Produces a standard error of estimate of each map. Image dataset. Come and look at this. So this is the digital ortho photos and satellite imagery. Then image datasets. Okay, this is what we're going to have. Then 3D analysis. We'll have something like this. 10 datasets. The triangle slides are constructed by connecting adjacent points so that minimum angle over each triangle is maximized. So triangle slides can not cross break lines, okay, as shown here. Mount patch feature. Okay, so summary. Three-code data implementation for vector data. We've got coverage, which is the ArcInfo, Shapefile, which is the ArcView, and the GeoDatabase, which is the ArcGIS. We will emphasize on Geo database in this class. So relationship based on attributes or on geometry metrics are used to connect related geographic features. ArcGIS components, we have the ArcMap, the Arc Catalog, the Arc Toolbox. Then the ArcGIS levels, we've got the ArcInfo, ArcEditor, and ArcView. Then desktop server, web-based sources of maps in Google Earth, web-based GIS, and KM on add-ons. So GIS extensions, we have a special analyst, then 3D analyst, and geostatistical analyst tracking. This has been present with the basic introduction to the GIS software. Till next time, bye.